Alright guys, I'm glad I'm here, and today we're going to solve implement strStr in Leetcode problem 28, considered easy. So what this question basically asks us to do is we're given two strings, haystack and needle, and there are a couple of cases that we need to think about. So we need to first of all check if needle is part of haystack, okay, this string, whether it's part of this string. At the same time, if needle is not part of haystack, such as this one, BBA is not substring of AAAA, then we should return -1. And if the length of haystack is length of needle is 0, meaning that if this is an empty string, then we should return 0 as an output. So let's just quickly read the questions. Return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack, like I just mentioned. Why should we return when needle is an empty string? This is a great question to ask in your interview. For the purpose of this problem, we'll return 0 when needle is an empty string. This is consistent to C strStr in Java's index of. That kind of makes sense, right? So first, we have to return if needle is a part of haystack. We should return the first occurrence is that index. So let's start by covering the exception cases. So if this is an empty string, right, needle, that's an empty string, meaning, if that's an empty string, meaning the length of the string is 0, then we should return -1. And if needle, so how do you check in Python whether a substring is a part of substring of another one? It's called in operator, right? But you have to negate it by putting not in, meaning if needle is not part of substring of haystack, then you should return -1. I'm sorry, the above case should return 0, right? And then, so once the program hits the line 12, the program already assumes, or it has pretty certainly that needle is part of haystack, right? So how do we check, or what kind of methodology or approach do we have to take to find the occurrence of the first element of needle? So first, as you can tell, we're going to use slicing. We're going to iteratively loop through haystack and slice by the length of needle, which is 2 over here. So I'm going to slice it HE. Is this HELL? No? Then move on. EL. Is this ELLL? No. Same as needle. Next, is it LL needle? Yes. Then I'm going to immediately return the index of that. Okay? So I'm going to do is over here. For I in range of index of length of haystack, I'm going to say, hey, if haystack sub I plus length of needle. In this case, why I'm doing this is if it's a 0, it's going to be 0 to 2. Okay? And again, the ending range in Python is not inclusive, so it's going to be 0 and 1s, which is 2. So it's going to check every 2's pairs of this string substrings here. If that's same as needle, then we're going to return I, right? Is that correct? Right? 0 to 2, 1 to 2. Yeah, so that's since the I is, so, beginning index. Let's see if this works. Okay, that's working. I hopefully pass all the, okay, that's fine, but how can we make it better? Like, is there any way that we could minimize or we could optimize this better? I think some of you guys might have noticed, but over here, we don't need to actually loop through the whole length of haystack. In this case, though, let's think about, so every time you think about time complexity or space complexity when you code, what really matters is like, all the time the question is, how could I make it better? So in this case, I'll think about like lower bound and upper bound, right? Since we know that we're going to return the first occurrences index over here, I'm going to think, hey, what's the best case scenario? This is what I'm going to ask and question to myself. The best scenario is definitely the output is 0, meaning that
the needles of sub 0 just appears as the haystacks of 0, right? If LL, think about it. If LL is located just very at the top, very at the beginning, that's the best. Even the loop just needs to the loop iterates only one time, and it will just directly finish and terminate the code. However, the worst case scenario over here, worst case scenario is output equals what? Output equals, I'm going to put just equal sign here, just to not to make, equals length of haystack minus length of needle. In this case, 5 minus 2, which is 3, 0, 1, 2. Actually, in this case, like minus 1. But okay, so as you can tell, this is the worst case scenario, right? Because we have to loop through that much. But still, this worst case is slightly better than the worst case scenario, which is hitting the end of. So what I'm saying is we don't need to loop through at the end of haystack. We only need to is minus length of needle over here. And since over here, let's think about it. So the answer is 3, right? Answer is 3. I got that. But what it really needs, it only needs to loop through the 4 over here, okay? 4, which is this plus 1. This is kind of like boundary theory. You can kind of look it up, and you can take your pencil and white notes, and you can kind of traverse through like each index very carefully. But this is just how many loop that I need to go through, okay? And this is definitely slightly better than needle, slightly better than just looping through whole kind of cases, because if needle is like really giant long, we don't want to keep checking the later down the road, right? So see, I don't think it's gonna like make it too fast, but at least it's gonna be a little faster than before, which is 17%, right? Because if you think about it, if the needle is like really giant long, you know, just by checking that much of a length of over here, as you can tell, length of haystack minus length of needle plus 1, it at least gives room to program that it does not have to go through the very far back of passing that kind of index, because we already know that once we check this, we don't need to check out the very last. So that was the idea. I hope you have a great day, and I'll see you next time. Bye bye.